So now in this video, this is kind of the first time where you need to take notes and kind of write down definitions and examples and everything. All right, so we're just going to be talking about our first big topic of calculus, which is limits. All right, so the first thing we're going to start with the definition. I broke down the definition to a bunch of different slides, so you only kind of get one thing at a time, and I can explain each step. So the first thing is we have a function, and it's defined, which means I can plug in all the values around x equals a. So just like one of our examples, we had something that looks like this. I can't plug in this exact value here because there's an open circle, but everything around here, all those values are fine. All right, so that's the basic starting point. I have a function, and everything close to what I care about works, even if it doesn't work exactly at the value I care about. All right, the next thing, let L, capital L, be any real number. So just a number, it'll be important what the number is, but for now it's just knowing L is a number. All right, we're gonna let x arrow a, that means we're gonna let x get close to a. All right, so we want our x values to get as close as possible. So again, if we think about the number line, in that table we had in the last video, we started here, our next value is there, 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 there. So we're trying to get really close to a. And it turns out our function values, and again, these are just our y values, those get close to L. So as my function values get close to A, my y values are getting close to L. So if that happens, as I get close to A, my function values get close to L, we say that that value L is the limit, all right, so that's the whole definition is for the word limit, of my function at the value A. So L is the limit of f of x at A if when x gets close to A, so as I get x values close to A, my output gets close to L. And this is the notation. So limit, basically for limit, think about getting close to A. This is just the function I care about. So this is the function f of x. And it's equal to that y value that's getting close to is L. So these are kind of the three big pieces of the limit notation. We have the value at the bottom, in this case x equals, or x is getting close to A. We have the function we care about, and we have our answer, which is that y value. All right, so that might be kind of confusing when you read it as a definition, but now we're going to look at some examples and kind of explain them. So this is our graph, and we're just going to go through a few different examples. All right, so the first one is, what is f of -8? And when there's no limit notation, all right, that's not here. This is just asking f of -8. What happens when I plug in -8? And this is just like that very first example we did in the last video. We get the solid dot. This is going to be -3. Because my function tells me that colored in circle is what I get. When I plug in -8, I get -3, because that goes across. But now we're going to change it and do the calculus thing. What is the limit as x approaches -8? So again, this is just our function. So now we're not looking directly at -8. All right, so I don't care about exactly what's happening on this line, but I care about the regions kind of just around -8. And what's happening just around -8? My graph is doing that. So in that small area just around -8, my graph is always down there, and it looks like the value should be there, which is -6. So the answer here is -6. It looks like the value should be -6. As my x values are in this region, all my y values are close to -6 down there. All right, what is f of 10? Again, now is a good time to kind of pause the video, figure out for yourself what f of 10 should be. But there's no limit notations. This is strictly just what the graph says. The graph says when I plug in 10, I get that solid dot. This is 0. What is the limit as x approaches 10? Again, I don't care about what happens right at 10, so I really don't care about anything that's on this solid red line. I just care about what's happening near it. And what's happening near it is that graph is going through that area, and it looks like it should be there. In this case, we get 0 again. There's nothing weird going on here. What the value is for f of 10 is the same as what it should be because there's nothing weird happening. All right, so there's one thing that the limit's not always different than the function value. Those are the interesting questions at the beginning, but they're not always actually different than each other. What is f of 6? F of 6, again, you can think about it for yourself for a second. But f of 6 is going to be, I go up to the solid dot, and it's going to be 5. All right, what is the limit as x approaches 6? Again, I don't care about what's happening just on this line. I care about around that line. Well, some y values are up here, some are down there. And what should the limit be? Well, one person could say 5 because the y values are around there. Another person could say 2 because there's some y values down here. And pretty much whenever you're in math and there's a problem where both people could say two different things and both be right, that actually just means it does not exist. All right, there's not going to be a limit at 6 because it's just argument. Some people think it's up here, some people down here. So the truth is, all right, the limit does not exist because of those two kind of differences at 6. All right, so there's a few different times that the limits will not exist. This is another example. What should the limit be at 2? All right, it's already nice. There's already a dotted line there. But again, some people say, well, the graph is going up here, so maybe the limit should be infinity. And some people say it's going down there, so maybe the limit is negative infinity because it's going to go down forever. But again, generally, there's two different answers and they both seem right. It means it does not exist. All right, this one I won't be able to show on the video, all right, but we can graph it on Desmos, which is an online graphing calculator. If you graph this function, it's going to look something like this. Right? It does kind of the normal sine things. On the outside, we know sine is just got a wave. And as it gets close to the middle, it does something like that. And if you were to zoom in on this really far, you'd basically get a picture that looks like this. All right. If you zoom in on Desmos, you basically almost end up getting an entire screen that's just red. And what ends up happening is this sine wave starts going up and down so fast that it basically turns into a solid block. And then the question is, well, what's the limit at 0? 0 is straight through the middle here. Again, we kind of have a thing. One person could say, well, it's up there. Some people could say it's down here. Another person could say there, 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 there. And this one's actually the worst of the cases because basically all these answers are what it could be or should be. And there's an infinite number of answers. That definitely means this does not exist. Okay. So these are our 3 ways that a limit won't exist. We can have a jump, so something like this. All right, so that limit's not going to exist because you have kind of competing theories. You can have an asymptote, so our example looked like that. Again, it's because you kind of have competing theories. You have a top and a bottom like that. Last one, oscillation, just means they have the kind of this squiggly pattern. And again, you have a lot of different options of what it could be. So whenever there's kind of a disagreement with what the limit could be, that just means it does not exist. All right, and the last thing, if you haven't already signed up for AP Classroom, I think the actual domain name is kind of weird, so just Google AP Classroom. It's the first link. All right, the code for our class is that. All right, and then once you have signed up, there should be an assignment on there, which you can do to kind of practice some of this limit stuff and looking at the limit notation and some graphs and just making sure you kind of understood what we covered in class today or in this video.